Okay, I've had a few questions about 2.7, the trig derivatives. The first thing I'll say is don't be too concerned on your exam. I would think there'd be a couple of multiple choice questions, and that's probably about it. But we should be able to do them. There's nothing here that's new beyond anything else you did on your last test. The only new thing is the idea that sine derives to cos and cos derives to negative sine. Everything else will be done exactly the same way as any of the questions that you did on the test. So just go over a couple of these solutions and hopefully we can clear up whatever confusion there was. So when I look at the first one, 2a, I have 2 times sine x times cos x. This is a product rule. The number out front, the coefficient out front, doesn't affect the actual result of taking a derivative of anything. If you think about just something like 2x cubed, we take the derivative of x cubed, and oh yeah, there happens to be a 2 out front, so we'll multiply the 3 that comes out of the derivative by the 2 there. So essentially the same thing here. Because it's going to be a product rule and it's going to be a couple of steps, I thought I'll just pull the 2 out front and bracket the whole expression, deal with the derivative in here, and then multiply by the 2 on the end. You can also treat it like I'm taking the derivative of this whole thing at the same time. So take the derivative of the sine, leave the 2 cos alone, plus leave the 2 sine alone, take the derivative of the cos. And then really the third step would be take the derivative of 2, get a 0, multiply it by sine and cos left alone. So you can handle it a few different ways. Like any other question, as we get into more advanced things, we do have more options available to us. Think about a really long, complex Bedmas equation, and obviously you can start in multiple different spots as long as you don't break the rules of Bedmas. So as we move forward here, I'm taking the derivative of sine, leaving cos alone, plus leaving the sine alone, taking the derivative of cos. The greens are the derivatives, although they don't show up terribly well right now. So cos times cos plus sine times negative sine. And again, this would be a fine final answer. I think the reason a lot of people had questions about this section was simply because they thought the answers in the back of the book looked quite different, probably from what you would normally expect to get. So all I did here was take some of the rules from advanced functions, cos squared minus sine squared. Some of you would recognize that as cos 2x. If you didn't, you might recognize it as, obviously I have cos times cos minus sine times sine, which is the addition of angles for cos rule. I forget my actual term there. So cos of 2x. So that's the answer in the textbook. All that said, this also, you may have noticed right off the bat, is sine of 2x. And so if you knew that, then we take the derivative of sine of 2x. We get cos of 2x times 2. And of course, we're done in one step at that point. But again, this is a fine answer. This is based on what we've done in calculus class. This is what I would expect you to get. 2f then, same, again, pretty similar idea, except I see now that I have a product rule up here and another product rule back here. And so exactly the same thing I did last time. The 2 is not going to affect the actual derivative, so I'm just going to leave it out front, factor it out for now, and then it'll be multiplied through it later on. If I chose to, I could treat this like I could have done the derivative of the x cubed and just left it as 6x squared. So there's my derivative times the 2 with the sine x. And then over here, and then plus the 2 times the derivative here. So 2x cubed left alone times the derivative of sine x, which is the cos x. And of course, we see that that's what we get in this line here anyways. Again, I'm just sort of thinking that factoring the 2 out, because it's not going to affect what I'm doing, was the easier way to go. I like the separation personally of here's the first part of the expression minus here's the second part of the expression, and I can clearly keep track of everything a little bit more easily. So if you get to this, obviously you've done it correctly, and then same sort of thing moving forward. And At the end, we simplify as much as we can. Oh, great, my emails are coming in. We simplify as much as we can, and then at this point I have x cubed with cos x's, I have x's with sine x's. There's really nothing I can do with this. Now the one question that did come in was, why did I put them in this order? The tendency when you're writing just a regular polynomial function is to put your x cubed or your highest powered x's, highest power terms, let's say, at the front. And so I'm basically just doing that. I have an x cubed here, an x squared here, an x here, and no x's, or an x to the 0 over here. Of course, in any other order, if the terms are the same, so if you have something like minus 3 cos x, and let's say plus 6x squared sine x, let's put the plus 3x sine x next, and the plus 2x cubed on the end. Of course, this is exactly the same thing, and it is perfectly all right as well. It'd be like somebody asking you, what do you have in your basket? And you say 3 apples, 2 oranges, and a banana. And somebody else says, no, 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 you have a banana, 3 apples, and 2 oranges. And somebody says, I don't think so. I'm pretty sure there's 2 oranges, 1 banana, 3 apples. Really, this is exactly the same thing. With all joking aside, that's the same idea as what I just said. So concepts from kindergarten do carry over nicely from to calculus and other courses. Don't overthink things. In question 3 specifically, we had to determine the actual equation. So take the work from part 2 a little further. So my original equation here is f at x equals sine x, and I'm given a value of x. So again, this is exactly what we did, even dating back to first principles. We found the slope using some sort of method, in that case first principles, in this case using derivatives of trig, and then we plug in the x value to determine what the actual number of the slope is, what the actual value of the slope is, more than just an equation for the slope. We take the derivative here, and this is now the equation to find the slope. And since I know that we're looking for x being pi over 3 specifically, plug that into that equation. And from grade 11, I guess, cos of pi over 3 is 1/2. For functions for sure, but again, from advanced functions for sure, but also from functions in grade 11, you probably did that. And if not, you plug it into a calculator, you see 0.5. I mean, for our purposes, that would be fine, I guess. In order to sub into my equation, the y equals mx plus b here, I need to know my y value, my m value, and my x. This is my m value right here. This is my x value, of course, up here. And now I need a y value. So into the original equation, remembering, of course, that y is exactly the same as f at x. They're completely interchangeable. So y is equal to sine of that x value, which is 3 pi over 2. And again, if you don't know that, then you're going to have trouble getting the exact answer written out, but you'd be fine to get an answer that is fine. And then we plug everything into our regular tangent formula. And again, this is the same formula we used day 1 when we were reviewing slopes and straight lines and so on. I have a y value. It's a little messier, obviously, than the ones I dealt with before. I have a slope. I have an x value. And basically, I multiplied by 6 just to simplify here. And so multiplying by 6, I get this, and this is my b value. Again, fine formula right here. But if you're looking to figure out why the answer in the back of the book looks different, they've essentially multiplied by 2 from this and rearranged it. So 2y, 2 times 1/2 x is just x. 2 times this divided by 6 is this divided by 3. And then we can simplify that section 3 root 3 over 3 and pi over 3. 3 root 3 over 3 obviously is just root 3. And then it gets subtracted to the other side over here. Negative pi over 3 becomes positive pi over 3 when it's added to the other side. And last one here, f at x equals this. If the steps will be the same, we have an x value, so this is my original equation. This is my slope formula, sorry. Take the derivative of that, I get something like this. To find the actual value of the slope, we have to plug in the x value where we're looking. And when we do a little math, we find that cos of pi is -1, sine of pi over 2 is +1, so it's -1 over here, and that all works out to -3. Again, this will be my slope over here. I do need an x and a y value as well. I have the x, of course, given to me. The y value will be from the original function. Plug in the pi over 2 and solve it down. Sine of pi is 0, cos of pi over 2 is 0. So pi over 2 is my x value, 0. Together they make a point on the graph. And so I can now plug those in and solve for b. I get 3 pi over 2. And again, to me, this is the best formula. This is actually the formula I would rather see. Last time I could say you can make an argument either way, but to me this is a much nicer formula. I like the y equals mx plus b form. Maybe that's just me. To get to the back of the book, they've essentially rearranged it. Oh no, they haven't, sorry. They've just factored out the -3. Total waste of time in my opinion. I like to see there's my slope, there's my y-intercept. That's why we have y equals mx plus b. I'm done my rant. And so factor out the -3. So essentially, I'm thinking that many of the questions probably stem from the fact that the book gave the answer in a very different form. There isn't a lot you can do there other than maybe if you take the answer from the back of the book, in this case, obviously multiply the -3 through, you would see that it is the same as the answer here. And the previous one would have been tough, I guess. To rearrange that and actually get it into the form of this one would have been a little tricky. So to some extent, it becomes a matter of sort of understanding the steps they've taken. To some extent, it's trusting yourself and checking with your friends and asking me, obviously, and seeing if we can get it cleared up if there are problems. So we'll call that quits. A little longer than I meant it to be, but hopefully you'll be comfortable with it. And again, we won't be getting a lot of marks on this section, but you will be seeing it next year, so it's fairly important that you have a chance to look at it now.